Greetings everyone, it's Anand here. Today we are going to be discussing on physics. Today in physics we'll be discussing about ST graph, VT graph, average velocity, average speed, non-uniform motion and also how to derive the slope of an ST and VT graph, the three cases and also the derivation of all the equations of motion. So before going into the derivation of graphs, I'm going to explain two important things, that is uniform motion and non-uniform motion. So let's say a body starts at point A and goes on till point B. Distance is AB. At speed 30 kilometers per hour. Okay? So that means there is no change in the speed. This is what you have to mainly understand, that from A is the initial point, B is the final point. So there is no change in speed whatsoever, which means from A to B, the body is going only at 30 kilometers per hour. It's not going to rest, it's not increasing the speed, it's not decreasing the speed, which means you can tell that the speed is constant. It is when a body travels equal distances or covers equal distances in equal intervals of time. This is known as uniform motion. So coming to the next topic of non-uniform motion. So non-uniform motion can happen in two cases. So now I'm going to be explaining the first case. The first case, the body, let's say it's traveling at the speed of 20 kilometers per hour, then increases its speed to 30 kilometers per hour, 40 kilometers per hour, and so on. So right now from the data what we have, we know that the speed is 20 kilometers per hour, 30 kilometers per hour and 40 kilometers per hour. This is non-uniform motion in a uniform rate. That is, the body is increasing its speed by 10 kilometers per hour at each time interval. So next I'm coming to is average velocity or speed. So how do you calculate this? So in this case, average speed of velocity would be V average. This is how we write. Is equal to U plus V by 2. This is a very important equation which you must know. Small letter u and small letter v. So u means initial velocity, whereas v is equal to final velocity. Okay, so you need to be really thorough with these two terms. Now let's substitute the values. So here initial velocity is the initial or the first velocity. So from the data given, just take the first one. Here in this case, it is 20 kilometers per hour. Next, final velocity. Wherever the data ends, that is the final velocity, or where the body ends its motion. 40 kilometers per hour. So from this we can easily calculate the average velocity. So how do you find it? Let me explain. So average velocity is equal to u plus v by 2. Now let's substitute this. Initial velocity 20. We'll put the units in later. But remember both are in kilometers per hour. 20 plus 40 divided by 2. We will get 60 divided by 2, which is equal to 30 kilometers per hour. So we can come to a conclusion that 30 kilometers per hour is the average velocity in this case. Now case 2 is what we usually consider as non-uniform motion. So the other one, case 1 was non-uniform motion in a uniform rate, whereas this is non-uniform motion in a non-uniform rate. So that would be like 20 kilometers per hour. It reduced its speed 10 kilometers per hour, and then 60 kilometers per hour. And so. So from this you can observe that the speed is not constant, it is variable. Here the object is slowing down by 10 kilometers per hour, then there's a sudden increase of speed with 50 kilometers per hour increase of speed. That this is non-uniform motion in a non-uniform rate. So how do you calculate average velocity for this? Simple, but it is not how we calculated for case 1. So in this case the average velocity is total distance divided by time taken. So that would be 20 plus 10 plus 60 divided by 1, 2, 3. 3 hours. 90 divided by 3. So 30 kilometers per hour is the average velocity where the object travels at non-uniform motion in a non-uniform rate. So coming to a definition, the definition of non-uniform motion is when a body covers unequal distances in equal or unequal intervals of time. So this is case 2 and the other one which we discussed was case 1. So one thing you have to notice, the equations for both of these cases are totally different, because in the first case it was average velocity equal to u plus v by 2, whereas in this case average velocity is total distance divided by total time taken. Uniform and non-uniform motion. And once you have mastered this, then you can understand all derivation of graphs and everything.